After understanding myopia, let us see numericals to understand myopia. Looking at this particular first question, the question says the far point of a myopic person is 80 centimeter in front of the eye. Now what does this mean? This means that in the case of a myopic person, if an image is formed till 80 centimeter, it can be seen clearly. So therefore the data which is given is nothing but the image distance. So we take this particular image distance as 80 centimeter. Now further the question says, what is the nature and power of the lens required to correct the defect? Now, what is the farthest point for a normal eye? The farthest point for a normal eye is infinity. So the object which is kept at infinity should be seen clearly by this particular person, and for that he needs a spectacle which will be decided from this numerical. So object distance is infinity. What we need to find is the focal length of the lens to be used and the nature. So let's start with this numerical. Firstly, what is given is object distance, and we know object distance is given by the symbol u, and that is infinity. Further, image distance. The image distance is v, and we can see image is to the left of the lens, therefore we take it as negative, so it will be minus 80 centimeter. Further, what are you supposed to find? You're supposed to find the nature and the power. Now, to find the nature and the power, let's see which are the formulas required. The first formula which is required is 1 upon v minus 1 upon u is equal to 1 upon f. And the second formula which is required to find the power is equal to 1 upon f. That is, the focal length should be in meters. Now let's go to the solution and let's put the values in the formula. When I put the value in the formula, 1 upon v minus 1 upon u is equal to 1 upon f. V is minus 80, so it will be 1 upon minus 80 minus 1 upon infinity is equal to 1 upon f. Now we know 1 upon infinity is 0, so therefore this equation becomes minus 1 upon 80 minus 0 is equal to 1 upon f. So therefore, further simplifying this becomes minus 1 upon 80 is equal to 1 upon f. So therefore from this I can say the focal length is equal to minus 80 centimeter. So students, as focal length is negative, it has to be a concave lens because the focal length of concave lens is negative. Now after finding this, let's go to the second part of this numerical and find the power. Now to find the power, the formula is P is equal to 1 upon f. So therefore, I know the focal length. The focal length was 80 centimeter. 80 centimeter is nothing but 0.8 meter. So therefore, this will be equal to 1 upon minus 0.8 meters. Multiplying, dividing by 10, this becomes minus 10 upon 8, and minus 10 upon 8 is nothing but minus 1.25 diopter. So students, let us understand what we did in this numerical. From this numerical, we found out that to correct this defect, a concave spectacles is required. Because when light will pass through a concave spectacles, it will diverge, and after diverging, it will go and fall on the retina and the defect is corrected. So this concave spectacles should have a focal length 80 centimeter and power 1.25 diopter. So the final statement, a concave lens of focal length 80 centimeters required and the power of the lens is 1.25 diopter. After looking at this, let's go to the next numerical. And in this numerical, the question says a myopic eye has a far point 2 meter. What is far point? Till 2 meters, that is 200 centimeter, if image is formed, it can be seen clearly. So therefore, what is given in the first data, students, is they have given us the image distance. So here, the image distance is 2 meter. Now further, what type of lens in spectacles would be needed to increase the far point to infinity? That means this person should be able to see objects at infinity. So therefore, what is given is object distance, and that is infinity. Also, last part of the sum reads, also calculate the power of the lens. So therefore, students, we need to find the power and the focal length. Let's start with the numerical. First, object distance u, and object distance u is infinity. Further, image distance v is equal to 2 meters, but image is to the left of the lens, so therefore we take it as negative. What are we supposed to find? The focal length and power. Now, to find this, let us see which formula is required. Once again, the first formula is the lens formula, that is 1 upon v minus 1 upon u is equal to 1 upon f. And the second is power is equal to 1 upon f. And focal length is in meter, of course. Now let's go and solve this numerical. Firstly, going to the solution, I use the lens formula. So it will be 1 upon V. V is minus 2 minus 1 upon U. And U is infinity is equal to 1 upon F. Now, when I come to this particular 1 upon F, therefore this becomes 1 upon minus 2 minus is equal to 1 upon F. So therefore focal length F is equal to minus 2 meters. Now as focal length is negative, it is a concave lens. So we understood that once again the lens that will be required for a myopic person is a concave lens. Let's go further and find the power. To find the power, a concave lens of focal length 2 meters will be required. So therefore power is equal to 1 upon F. Now when power is equal to 1 upon F, therefore this will be equal to 1 upon minus 2. And 1 upon minus 2 is nothing but equal to minus 0.5 diopter. So therefore students, what did we do again? We used a concave lens. And this particular concave lens diverges the rays and the rays fall on the retina. The concave lens has a focal length 2 meter and power 0.5 diopter. Whose final statement, the concave lens of focal length 2 meters is required and the power of the lens is 0.5 diopter. So students, these are the numericals to understand myopia. Thank you.